can we recap on the formula first? If you want to rotate about the x-axis, then the formula is pi y squared dx. Okay, there's an extra pi and a square for volume. If you're rotating y-axis, it's pi x squared dy. These two formulas are for one curve. The next part below here, I talk about these two diagrams. They will be for regions that have two curves involved. I'm going to rotate this on the x-axis. The question will tell you where to rotate. When you rotate on the x-axis, if your region is bounded by two curves, you will need to judge who is the outer and who is the inner curve. And this is with respect to your rotation axis. You would like to check which curve is further and which curve is nearer to the rotation axis. Personally, I will not visualize the diagram. I wouldn't think about what is the 3D shape. We just go for outer and inner. So what do I mean by that? If this is your rotation axis, y1, which is this curve, is the outer because it is further from the rotation axis. Okay, let's call that as the outer curve. y2 that is below here is called the inner curve. And when should we identify the outer and inner curve? Because you see over here, this whole segment, I call this a gap. There is a gap between the region and your axis. If there is a gap appearing, then there must be an outer and inner curve concept because your region is in between two graphs and there is a gap. Okay, so with a gap, always outer, inner. Let me write down now the volume. So I say outer minus inner, meaning remember to put pi, sometimes we forget. It's y1 square minus y2 square dx. Square individually first, then you subtract. On the right, I would like to do that rotation about the y-axis. Let's rotate here. So if I rotate across the y-axis, this time x1 here on the right side is the outer. For volume, it's not about upper, lower, or right, left. It's all about outer and inner. So this is the outer curve, and this is the inner curve. Okay, so let's write down your volume equation. We go for pi, outer square minus inner square dy. Okay, so let's apply it to these two questions. Short example, you have the same two graphs, but I shaded a different region. Can I rotate them across the x-axis? When I see the question asked for x-axis, I will remind myself first that this is the formula I want to aim for, which means that in your equation here, you need y to be the subject, which we already have, but is to remind ourselves it's y squared dx. How do we cut up the diagram? One concern many of you have is, how do I know which region should be separated with each other? So you should cut up the diagram carefully. You cut at these points. I explain what is cut. I want to chop up the regions basically. Number one is endpoints first. Can we identify what are the end values, okay, for your region? The end values for your x, extreme left is at 0, extreme right is at 2. I identify the ends first. That's number one. Number two, in the middle, you ask yourself, should I cut it up again? You cut it up if you see intersection points between the two curves. Do I have intersection between the two curves here? There is. So you cut up one more time. And number three, doesn't appear in this question, but other questions there may be, you look for any x intercepts between your curve. I'm using x only because we are rotating x-axis. If you are rotating y-axis, you check for y-intercepts. It will differ accordingly. In this question happens that my end limit is at the x-intercept. So I don't need to cut one more time. It's nicely sitting on the x-intercept. So after you cut your diagram, then here clearly we see it's chopped up to two regions. So you check these two regions separately. There is no gap towards the axis. Your shaded region nicely touches the x-axis. So there won't be an outer and inner. Outer and inner must have a gap to the axis. So both of them, we just integrate directly. Region 1, I integrate from 0 to 1 over root 2. Straight line and y squared dx. Region 2, 1 over root 2 to 2, y squared dx. The diagram on the right, again, can we cut the diagram first? Extremes. Any intersection already cut. Any x-intercept don't have. Okay, so this is it. There's only one region like that. Any gap or not? There's clearly a gap here. There's a gap from the shaded region to the x-axis. When there is a gap, then that segment will take an outer and an inner curve. Only when there is a gap appearing, then you identify outer and inner. Okay, so now we integrate only one region, 1 over root 2 to 2, and we take the outer square minus your inner square dx.